Hello there, welcome to October 2020 paper 2. Here we're looking at question 6. So M is equal to this matrix here. Find in terms of K the inverse of matrix M. Okay, so first of all we need to find the determinant. So the determinant of the matrix is going to equal K, lots of cross out the row, cross out the column, that would be minus 2. Then it'd be minus 5 times cross out the row, cross out the column, minus 1, minus another 2, so it'd be minus 3. And then it'd be plus 7, lots of 1, minus 2 is minus 1. So just a reminder here that it goes plus, minus, plus, minus, plus, minus, plus, minus, plus on your coefficients. So the first K coefficient is a plus, the 5 will have a coefficient of a minus, and the 7 will have a coefficient of a plus. So that's going to give us minus 2K minus 15, no, plus 15 for the double negative, and then minus 7. So therefore this is going to equal minus 2K plus 8. And that does make sense because K cannot equal 4, so therefore, yeah, that does make sense. So therefore that's the determinant. Now moving on to the matrix of minus. So now we're going to do the same, crossing out the row, crossing out the column, but not the timesing by K, 5, or 7. So cross out the row, cross out the column, and you've got minus 2. Then it'll be minus 3, then it'll be minus 1. If you've done the working, you've got your 3 first answers on the here, here, and here. Then on this next row, it's going to be cross out the row, cross out the column. So it's minus 5, minus 7. That's minus 12. Middle one, that's going to be minus K, minus 14. Next one is going to be K minus 10. Bottom left now, so it's cross out the row, cross out the column. 5 minus 7 is minus 2. Middle bottom now, minus K, so no, it's going to be K minus 7. And then the final one is going to be K minus 5. So now we're going to, this is the matrix of minors. So now let's transpose it. And what that will do is it will keep the leading diagonal the same, and then flip over the other ones. So it's now going to be minus 12 here and minus 2, and it's also going to be flipping over K minus 7. And then this one will flip over to this side, so minus 3, minus 1, and K minus 10. So it flips over in the leading diagonal. Let's now apply the matrix of cofactors. That's this matrix at the top here. This is the matrix of cofactors. So anything in the plus position stays the same, and anything in the minus positions gets flipped sign. So minus 2, minus 2, minus 1, K minus 5, and minus K minus 14. Their signs will stay the same. That's a minus 14. And then anything in this diamond kind of shape here will have their signs changed. So it would be 12, 7 minus K, and 10 minus K, and 3. So therefore the final answer is now 1 over the determinant. So M inverse equals 1 over minus 2K plus 8. And then it's going to be this matrix here, minus 2, 12, minus 2, 3, minus K minus 14, 7 minus K, minus 1, 10 minus K, and K minus 5. So there we are, that's the answer for question A there, so 4 marks for that inverse matrix. Let's now move on to part B. So find in terms of P the coordinate of the point where the following planes intersect. Okay, so if we write this question as a matrix question, then it's going to be 2, 5, 7, 1, 1, 1, 2, 1, minus 1 times x, y, z equals 1p2. And find the coordinates, find in terms of P the coordinates of the point where the planes intersect. Now what we'll do then is we'll look back at the matrix that we had before and note that it's the same matrix that we had before, just k equals 2. So we'll apply k equals 2 and then inverse it onto the other side. So now what we're going to do is pre-multiply by the inverse of this 3 by 3 matrix. So if k equals 2, then the matrix is going to be 1 over 4, because it was 1 over 8 minus 2k. 1 over 4, then it's going to be minus 2, 12 minus 2. Then it's going to be 3 minus 16, 5, minus 1, 8, minus 3, multiplied by 1p2. Now that's the same as the inverse of the matrix before, just where k is equal to 2. Let's now multiply the matrices together. So remember, you multiply it going along, and then you multiply going down, and then add your results together. So it's going to be minus 2 plus 12p minus 4. On the next row, it's going to be 3 minus 16p plus 10. Moving on to the next row, it's going to be minus 1, 8p, and minus 6. So therefore now let's simplify it with the 4 included. So it would be minus 6, so that would be minus 6 over 4, so that would be minus 3 over 2, plus 3p. Moving on to the next row, it's going to be 13 over 4 minus 4p. And moving on to the final row, it's going to be minus 7 over 4 plus 2p. So therefore the coordinate is, write this just in horizontal form now, minus 3 over 2 plus 3p, 13 over 4 minus 4p, and minus 7 over 4 plus 2p. Okay, so there we are. So that's the answer to part B. Let's now move on to part C. Oh, sorry, there's a typo on this question here. It should say k at 4x up there. So find the value of q for which the following planes intersect in a straight line. So we've got 4x plus 5y plus 7z equals 1. So that's why I had to change that, because I know that k is equal to 4 for this question here. So this question here is looking to you to find the value of q for which the planes intersect in a straight line. So what they're looking for you to do in this question is to solve it as if it were a sheaf question, which is where you make your simultaneous equations and then solve them as if they were simultaneous equations. So 4x plus 5y plus 7z equals 1. X plus y plus z equals q. And 2x plus y minus z equals 2. So which letter would we like to eliminate? Probably eliminate the x letter. So if we call this one equation number 1, this one equation number 2, and this one equation number 3, then what I'm going to do first, I'm going to do 2 times 2, and then minus equation 3. Okay, so be very careful here. So it's 2 times equation 2 and then minus 3. So 2 times equation 2 will give you 2x, and then minus 2x will give you no x's. 2 times y will give you 2y, minus y will give you y. 2 times z will give you 2z, minus z will give you 3z. And then on the right hand side, it's going to be 2 times q is 2q, minus 2, that would be 2q minus 2. Okay, let's do the same thing with equation 3 and equation 1 now. So I'm going to double equation 3 and take away equation 1. So it's going to be 2 times 2x, which is 4x, minus 4x, which is 0x. 2 times y, which is 2y, minus 5y, that would be minus 3y. 2 times minus z, that will give us minus 2z, minus another 7z, that would be minus 9z. And then this equals 2 times 2 is 4, minus 1 is 3. Now what we can clearly see here is there is a scale factor from the first equation here of the intersection. This equation here is effectively intersecting 2 and 3. This equation here is clearly intersecting 3 and 1. So these equations here must be the same if they form a sheaf. So there is a scale factor of -3 from one to the other on the coefficients, certainly, and the same coefficient must, the same scale factor must be the same on the numbers on the end as well. So it's -3 times the first equation equals the second equation. So therefore 2q minus 2 equals -1. So therefore 2q equals 1. So therefore q equals a half. So there we are, we have q equals a half on the q side. And now for part 2, it's for this value of q, determine a vector equation of the line of intersection. Okay, so a pretty tricky little question, this one. Now what I want you to do is imagine that you've got 3 planes that are intersecting. So you've got one plane maybe here. It's very difficult to draw this, so please do forgive my drawing. You've got one plane here and maybe another plane here. And all 3 of these planes are intersecting along the same line. Okay, so now given that we want to find the equation of this line here, what we already have are all of these n vectors. We have one n vector here, we have another n vector here, and we have another n vector here. And the n vectors are clearly the coefficients on your planes. So the first n vector, n1, is 4, 5, 7. The second plane is n2. Second perpendicular vector is 1, 1, 1. And the third perpendicular vector is just the coefficients on the third equation, 2, 1, minus 1. Now, all of these, this line that we're trying to find will travel along all 3 planes, because that's where the 3 planes intersect. They intersect along this line, so it's going to be a line that exists within the plane. So let's therefore give it an equation. Let's give it the equation a1, a2, a3 plus lambda lots of b1, b2, b3. So let's give that line an equation. Now what's going to be the property of that line is that it's going to be perpendicular to all 3 of these planes here. So this direction vector here will be perpendicular to all 3 planes. So therefore what we could say is, in fact, actually we could make this problem a bit easier if we just reduce b1 to 3 and then scale factor up if we've got any fractions in b1 and b2. So I'm going to refer to it as that for now. I've just scaled it down to the z component equals 1. And now what I'm going to do is I'm going to choose my 2 easier planes, which will probably be n2 and n3, and make some simultaneous equations out of them, because what's going to happen here is this line will be at a perpendicular to all 3 of these n vectors, so therefore the dot product is going to equal 0. So therefore, first of all, b1, b2 and 1 dotted with 1, 1, 1 will equal 0. So therefore, b1 plus b2 plus 1 equals 0. And let's do it with the other easier vector as well. Doesn't matter which vector you choose here, but I'm just choosing the easier ones. 2, 1 and minus 1 equals 0 will be 2b1 plus b2 minus 1 equals 0. Now let's subtract one equation from the other. We'll call this equation 1, we'll call this equation 2. And we'll do equation 2 take away equation 1. So that's going to give me b1, and then it's minus 1 minus another 1 will give us minus 2. Add that onto the other side and you get 2. And then b1, so b2, will therefore equal minus 3. And that's fine, so that will give us a z component of 1. So therefore, at the moment, we now have worked out the line, the direction vector of the line. And just to remind you, the way that we worked out the direction vector of the line is because we knew that the direction vector of the line would have to be at a right angle to all 3 of our perpendicular lines. So it's going to be b1 first, that's 2 minus 3, 1. Right, okay, so now the next thing to do is going to be finding a point on the line that is going to intersect that's going to intersect this line. Now what I'm going to do here is I'm going to be quite cheeky and I'm going to set A3 equal to 0, because if it is a line and it has a direction vector of 1 on the lambda, then at some point along that line, A3 is going to equal 0. So now what I'm going to do is I'm now going to... So what I'm effectively doing when I'm setting A3 equal to 0 is I'm setting the Z value equal to 0. And now what I'm looking to do is just find any coordinates that satisfies all three of these equations here, and that would be my starting coordinate. So if I now take the first two of these equations, 4x plus 5y, and then z will equal 0, just because at some point along this line z will equal 0, and then x plus y equals a half, and solve that using the simultaneous equation, solve it on my calculator, I get x equals 3 over 2 and y equals minus 1. And let's just check, plug these three values back into all three lines and it should give you the answer. Particularly check the third one, because that one hasn't been used yet, so it's going to be 2 times 3 halves, that would be 3, plus minus 1, so that would be down to 2, and then minus 0, so that is 2. Yes, excellent, good, so it does work there. So we have a coordinate on the line. A coordinate on the line is 3 over 2, minus 1, 0, and that is what effectively coordinate A is. It is just a coordinate along the line. So it's going to be 3 over 2, minus 1, 0. Now there's so many different answers you could have for the starting coordinate. This starting coordinate here is just any coordinate along the line. And then it's plus lambda lots of 2, minus 3, 1. So there we are, that's the equation of the line that will intersect all three planes. And that's how we worked it out. We worked first out the direction vector by using our knowledge that the direction vector of the line is going to be perpendicular to all three planes, and therefore by setting the z component equal to 1, we can work out what b1 and b2 are. And then so we worked out then what the direction vector was, and then we worked out just any random starting coordinate for our line. We worked out if we put z equals 0, then 3 over 2 minus 1, 0 is fine, and then we just put it into the form of a line. So very difficult little question there on the end there. 14 marks in total for question 6. Very well done if you got through that and if you understood it. Let's now move on to the final question of the paper, question 7.